We'll start, but the people will join. Unit number 5, which consisting of linear programming problems, both in graphical way as well as by traditional way that we have called algorithmic way. For algorithmic way, we have 3 more methods: simplex method, revised simplex method, G1 simplex method. But we start with the graphical way. So linear programming problems by graphical approach. Let us start with the graphical approach. So what is linear programming problems? Actually, whatever your objective function, which we have started with unit number 1, your objective function and constraints, both are written in terms of linear combinations. Both objective function constraints are written in terms of linear combinations. That means there won't be any complexity either in the objective function or in the constraints. So you won't have any logarithmic functions or exponential functions or trigonometric functions. Only as a linear function. That means your objective function, let us say your objective function is something like 2x1 plus 3x2. Fine. Similarly, your constraints. What we have solved, we have formulated the problems in the first unit, will all falls under the LPP problems. So your problems will be 2x1 plus 5x2 is not equal to 100. So if you have written all the constraints or the objective functions will be of only linear. That's why they are called linear programming problems. So we can solve these LPP problems either by graphical way or by algorithmic way. So in the graphical way, what we do is we try to plot on the graph sheet what are the variables given in the problem. Then we try to, let me write here, plot the variables associated with the objective function and constraints. First step, and then find the feasible region. With respect to given constraints. Then find the optimal solution. Across all points of the feasible region. So these are the 3 important steps in graphical method. What we do is first we plot, and then after plotting we try to find out the feasible region with respect to what is the constraints given, and lastly we try to find out the optimal solution across all the points of the feasible region. That means, for example, if this is the problem, let us say your objective function is, let us say 2x plus 3x2. What we do is we try to plot a graph representing x1 on the x-axis and x2 on the y-axis. Fine. So we try to plot whatever the constraints given. How many constraints given? We will try to plot it on this graph sheet. And then after plotting the graph sheets, the constraint, we need to find a region, feasible region. And those feasible region is with respect to the given constraints. So whether the constraints is greater or equal to 0 or less than or equal to 0 or greater 0 or less than 0, we need to check with the constraints, find out the feasible regions. Then last step is, in that find out, we have found out the optimal solution. Like for example, for any point of the region, we will find out keeping the objective function, whether the objective function is maxima or minima, we try to attain. Okay. So let us solve the problem so that we come to know. Solve the following LPP problem. Solve the following LPP problem graphically. Solve the following LPP problem graphically. Yes, maximize z is equal to maximize z is equal to maximize z is equal to 3x1 plus 4x2. Z is equal to 3x1 plus 4x2. That is, this is your objective function given. Now subjected to so constraint is given 4x1 plus 2x2 less than or equal to 80. 2x1 plus 5x2 less than or equal to 180. And x1 comma x2 greater or equal to 0. So this problem we have already seen. Like we have formulated the objective function from the given problem. Fine, we have done in the unit number 1. How we got this objective function or constraints? By looking at the problem given, we have solved so many problems. Is it not? We have different varieties of problems we have solved. Medicinal problem, carpentry problem, chains, desks. Lot of problems we have solved. We have formulated the objective function, we have calculated the constraints. So everyone knows why this x1 x2 greater than or equal to 0. Everyone knows why this should be 0, whether it is greater or equal to or lesser or equal to, at least, at most. We have solved all those things in unit number 1. Now the extension of unit number 1 is unit number 5. After framing your objective function and after framing your constraints, how to get the optimal solution? Okay, what are the steps in LPP? If you solve graphically the same problem, you can solve the same problem either by graphical way or by simplex method. That is the traditional approach. Let us solve by graphical way. How we solve? The first step in the graphical approach is, first of all, you plot the variables associated. So just like here, I am plotting x1 on the x and x2 on the y because the variables are x1 and x2. x1 and x2. Now after plotting, what is the second step? We need to find out the feasible region. What is the third step? We need to find the optimal solution. Now just look at the graph. Maybe I can plot it. Just look at the board. Okay. So we need to plot now the given constraints. We need to plot these constraints on the graph sheet. And then after plotting, we need to find out the feasible region. That's the second step. So let's check this first equation. This equation we need to plot on the axis. How do you plot? How do we plot 4x1 plus 2x2 less than or equal to 80 on the graph sheet? How do we plot? How do we plot? Huh? Is the linear equation? No, this equation I need to plot on the graph sheet. How we plot? I am asking. How we plot? Huh? Yeah, the only one way is give Give different values of x1, subsequently find out x2 values and you plot it. That is traditional way. But I am giving very simplified shortcut method of plotting the equations. Just look at here. If you want to plot any linear equations, very simply you can plot on the graph sheet. How we can plot? Just take the first equation 4x1 plus 2x2 less than or equal to 80. Maybe I can write here 2x1 plus x2 less than or equal to 40. I just divided the two. Now what I do is, for time being, instead of less than or equal to 40, I just made equal to 40. Look at the board. When you are making it equal to 40, for time being only, later we will check out what is the concept actually given. First we will make it equal to 40. Then what the shortcut way of plotting this equation on the axis is, just put x1 equal to 0, you will get x2 value. Similarly, put x2 equal to 0, you will get x1 value. And mark those x1, x2 and join the line. Because it's a linear straight line. Very simple way of plotting on the graph sheet. If I put x1 equal to 0, what is x2? 40. If I put x2 equal to 0, what is x1? So you just mark those points. x1 is 20, x2 is 40. x1 is somewhere around 20. Maybe I can plot it here. Maybe it is 10. Maybe it is 20. So x1 is 20, x2 is 40. Maybe here 10, 20, maybe 30, here 40. So this is the 40 point. So if I join this as a straight line, it will be somewhere here. So this line represents your equation 4x1 plus 2x2 equal to 40 or 80. Very simple way. What I did is, if I want to estimate x2, keep x1 0. If I want to estimate x1, keep x2 0. Provided you should make it first equal constraint, that is equality, rather than some other constraint given. Let us put equality constraint and solve it. Similarly, let us find out for the second equation 2x1 plus 5x2 less than or equal to 180. So keep x1 is equal to 0, find out x2 value, keep x2 equal to 0, find out x1 value. Now you mark it on the graph sheet, do it. You have to plot on the graph sheet. So take a graph sheet. Take graph sheet. Mark the point. Draw the two straight lines. Take a graph sheet, draw the line. So now mark the point x1, x2, draw the straight line using the scale. So first line is now second line to plot. Take equal distributions without any disturbance. What is there on the x-axis units, keep it same on the y-axis unit. So what is the second line? How it will be? So second line, what is x1 value? What is x2 value? Second line. x1 value, how much you got? x1 value? 90, yeah? Yes, what is x2 value? x2 value? 30? 36, correct. Now your x2 is somewhere 36, maybe here see. This may be 30 means 36 somewhere here, so 36. Your x1 is somewhere 90, so that means it will keep it somewhere will be around, let us say this is 90. So this may be your next line. This may be your next line, that is this line. 2x1 plus 5x2 less than equal to 180 equation. So first draw the lines first. Draw the two lines. Perhaps you might well get like this. You get the two lines will be like this. Is it over? Then draw the two lines. Draw the two lines. Draw the two lines. Now let us see. See, we need to plot the other constraints also. The other constraints are x1 greater than or equal to 0, x2 greater than or equal to 0. Because they are not any straight lines, we are unable to plot, but we need to account these constraints also. Keep in the mind. Because all the constraints we need to account in order to find out the feasible region. Fine? We need to account. Now look at the board first. These two equations have plotted by making equal constraints. But now they are not equal. They have been given some constraints less than or greater than, whatever it may be. See, given both are less than. The step number 2 says find out the feasible region. What do you mean by feasible region? Feasible region means bounded area. Bounded area, that means with the constraints, which area is completely bounded by your constraints given. Fine. For example, maybe some part of your constraints will be like this, other part of the constraints will be like this. For example, let us say that which is the bounded area. Bounded area means which map or which considers all the constraints. That means this part. If you just look at this part contains both bounded regions. So this part is your bounded region. So feasible region. Now we need to do that same here in this problem. How do you do now? Because this equation is already known, we plotted, but taking into consideration of equal symbol. But we need to look at less than or equal to symbol. Now we need to be very careful. Whether the area of this equation will be that side or this side. Because this is the line. The first line is this one. So this line, I need to mark that side or this side. Very simple. This is also very simple. What we do is, see, this is the line. Now take any point right side of this line. Maybe any point right side of this line is what? Maybe let us say x1 is somewhere 20, x2 is somewhere 50. Outside of this line. So let us keep x1 as something 30, x2 as something 50 in this equation. What you will get? 120 plus 100. 220. 220 less than 80? Wrong. That means this is not in this side, this will be this side. So your zone of lines for this straight line is in this way. This is the part of this equation. Mapping with your constraint less than or equal to symbol. Understood? How I have done? After drawing this line, I took any point right side extreme and I have checked in the equation. If it is satisfies means right side part only. I need to mark lines that side. But I get that is wrong option. That means my point is not this way. This is opposite. That means my lines are this way. Similarly, do it for this equation. 2x1 plus 5x2 less than 180. So this is this line. Maybe you check any point outside this line and check whether the constraint is correct or not according to the symbol given. Maybe you can take x1 as something 100 because this point outside this point and x2 as something around 40 or 50 but maybe you keep it here 200 plus 50 into 5 250. So it will be 450 less than 180 wrong. So that is not that side, this side we need to mark. So now the second line is this part. Just check that, this part. So I am just marking lines in this way. See, this complete line will be marking in this way. Fine. Now third constraint. Third constraint is x1 greater than or equal to 0 means what? What is x1? This is x1. x1 is greater than or equal to 0 means complete this zone. This line. Fine. Complete x1 greater than or equal to 0. Next x2 greater than or equal to 0. x2 is this part. So this will be this part. Now look at the shaded area. If you look at observe, see. All are mapping in this zone if you look at clearly because these lines are mapped here, these lines are mapped here till this part only. You just look at here because see this line is coming in but this line ended here itself. So this portion is not the constraint closure, only this part. If you draw, you will get this zone as your shaded area. So if I could plot, maybe somewhere like this way. Maybe this shape of the curve will come. This zone is your feasible region. That is second step. That is second step. That is second step. Now what is the third step? Finding the optimal solution among all the points across the zone. So what are the points? So this point is 0, 0. So this is 0, 0. Now what is this point? No, not this point. This point. This is x1 is 20, x2 is 0. This point is 36. x1 is 0, x2 is 36. Now what is this point? This point. How to find out that point? See, this point is nothing but intersection of this line and this line. That means intersection of these two lines. That means two equations, two unknowns. Solve to get this point. So I get the answer. x1, x2 first point is 2.535. 2.535. So this is the point. This point. Maybe I can mark it as A, B, C, D. A, B, maybe C here, D here. A, B, C, D. So the B point is intersection of the two lines. If I solve the two lines, I get 2.535. Now how to find the optimal solution across all the points means for every point, that is point A, B, C, D. For every point, find out your z value. That is, what is the function value? What is the function value? Z is 3x1 plus 4x2. Keep the point A there in that equation. Find out the value. Keep the point B. Find out the value in this equation. Keep the point C in this equation. Keep the point D in this equation. Find out all the z values. Maybe I can put the values also. if I keep 0, 0, I will get 0, point D. If I keep 20, 0, I will get 20, 0 means what? C. For C, I will get 60. Answer is. For B, I will get 147.5. For A, I will get 144. Just I am substituting the points. I am substituting the points in the function given, objective function given. I got 144, 147.5, 60 and then 0. Now what is the problem given? Maximize or minimize? So how among all three, which is the maximum? So the point B is your optimal solution, because that is the only point is giving highest maximum value for the given objective function with the given constraints. Okay? Understood? I am again explaining how to solve the graphical way LPP problems. First you draw the equations on the axis. X1, X2, maybe sometimes X, Y, whatever it may be. First you make it as equal constraints. There may be unequal constraints given, but you first make it equal and get the values. So keeping X1 equal to 0, get X2, or X2 equal to 0, get X1, plot it first. Then the next step is finding the feasible solution. In order to find the feasible solution, you need to mark the lines. Which side according to the constraint given? This side or this side? So very careful in that point. So if you want to find out that, what do? If this is a line, take any point above that line and substitute there. Whether you are getting mapping with the constraint or not. If it is mapping, that means you mark lines above. If it is not mapping, mark it downward. And then next point is find out the zone where all lines are coinciding. So find out that area. Now in that area, find out the optimal solution. That means take all the points, substitute in the given objective function, and note down the values. And look at the problem given, maximum, minimum. Problem is maximum, means highest maximum value which is obtained, that will be your optimal solution. Okay, fine. Now you do on your own the problem. The objective function z is equal to 5x1 plus 3x2. And the constraints are, subjected to constraints are 4x1 plus 5x2 less than or equal to 1000. 5x1 plus 2x2 less than or equal to 1000, and 3x1 plus 8x2 less than or equal to 1200, and x1 comma x2 greater than or equal to 0. And this is the problem to maximize the profit. Now do it now. Take a graph sheet, plot the lines, find out the region, and tell me the optimal solution. for this problem. So this point, maybe if I can see, maybe if it is B, maybe if it is A, if it is D. So I am listing out what are the ABCD points. A, B, C, D. So your A is 200, 0. Your B is around 3,570. And the 1,570. Your C is 2,070. 1,870. And D is 0 or 50. And your 0 point is 0, 0. And find out the jet value. Have you got this? Have you got this? The shaded zone like that. The shaded portion. And you find out the locations of B and C. Solving the two equations. You get like that. This portion will not come into your shaded part. You remember? You see, this part is not will not come here. Because see, maybe this line is having, but this line is going in. So this line is missing here. So this will not come. Only below this only it will come the shaded part. So this portion will not come. Similarly here, this portion will not come. Have you got? Point number C, be around zero. See how we got point number C. This is intersection of this line and this line. And B is intersection of this line and this line. Don't confuse. C and B are intersection of different line segments. The C is intersection of this line and this line, whereas B is intersection of this line and this line. అందుకోసమే లైన్ ని మార్క్ చేసుకోండి ఏ లైన్ మేబీ ఈక్వేషన్ 1 అనుకోండి ఇది ఈక్వేషన్ 1 ఇది 2 ఇది 3 అనుకోండి అక్కడ అర్థం చేయండి ఏది ఈక్వేషన్ 1 ఏది 2 ఏది 3 1 3 ఇంటర్సెక్షన్ 2 3 ఇంటర్సెక్షన్ చూసుకొని ఫైండ్ అవుట్ చేయాలి ఓకే Okay, fine. The next variety of problems lies in directly asking to formulate, which you have done already. Maybe for example, if you go back your note, open the first problems where we have done milling problems or cane apple juice problems, where the entire problem will be given and ask you to solve by LPP. That means what? We need to first formulate the objective function, we need to formulate the constraints, and then after getting the objective function and constraints, we need to plot. Okay? Fine. So maybe all the problems which we solved in the classroom, maybe I think 15 to 20 problems we have solved. All the 15 to 20 problems, maybe ask you to give a first direct heading, solve by graphical method, LPP, and then give this problem. So we need to first assume the variables which you have started in unit number 1. Formulation of optimization problems we have solved. So we assumed what is unknowns. Let x1 be weight in terms of something like we assumed. Then we formulated. Then after formulation we need to solve by the graphical method. Fine. So that is second variety of problems. Instead of directly giving the equations, he won't give the equations. Just what we have done in the unit number 1. A problem will be given, entire statement. Fertilizer production, I have given in the first mid examination. So the fertilizer problem may be the profit or what may be the yield or the weights, which to be maxima, which to be minima, we have written, we have solved. So after formulation of the problem, we need to attempt the graphical method. Fine. Now note down the exceptional cases in LPP. Exceptional cases in LPP. Note down. There are some exceptional or special cases in LPP. There are some exceptional or special cases in LPP. First one, no feasible solution. First one, no feasible solution. No feasible solution. Second one, unbounded solution. Second one, unbounded solution. Unbounded solution. Third one, more than one optimal solution. More than one optimal solution. Fourth one, redundancy. Redundancy, REDUNDANCY, redundancy. REDUNDANCY, redundancy. These are the 4 exceptional or some special cases in LPP. Let's look one by one. What is the first one? No feasible solution. When you will get no feasible solution? See, when we get some feasible region, we got the feasible solution. If you won't get the feasible region, you will not get feasible solution. So what is the first one? The exceptional case is no feasible solution means sometimes what will happen, the constraints are not forming the feasible region. Let us say for example, if this is the problem, there is one more equation which is given like this, in which the lines are opposite. Then when we get the feasible solution, if the lines are in this way, I can find out, okay, what is the common zone, I can find out. But this time the constraint says it should be that side. No, I cannot get a feasible solution here. I cannot get a feasible region here. So sometimes some of the constraints may fall in this way. Some of the problems. So that is called first one. No feasible solution means there is no feasible region obtained from the given constraints. That means one of the constraints is different from the other constraints. Okay, that's the first one. The second one is unbounded. What is unbounded? Unbounded means sometimes we need to get the maximum. For example, in this given problem, maximization we ask it. Given problem, maximization asked. But the constraint says it is open, it's unbounded. That means see, some of the constraint is in this way. But whereas other constraints are in this way. Oh, when you are only inside, then only you can get the solution and where you can get the location of maximum. But one of the says it is open. Open means there are more unbounded. Or let us say same lines. Let us say for this problem. All the lines, let us say, not marking downward. All the lines are going up lines, let us say. Now you tell me what is the feasible region for all the lines that is opening. That means all the lines are going upward. All the lines going up. Then where is the region? Because going up means there is no region to close it. For example, if it is going in, it is closed by this boundary lines. It is closed by this boundary lines. But sometimes the constraints are on the other side. That means open-ended. So if it is open-ended, where is my region to identify the points? So that is second one, unbounded case. Now third one, more than one of one solution. More than one of two solution. For example, after getting the points you have marked here, let us say some of the points got same value. Let us say for point B also you got Z value 1, point C also you got Z value 1. Then what? More than one of the solutions satisfying the given objective function. Third case, exceptional case I am talking, or special cases. Sometimes you get more than one solution. That means more than one or two points got the same Z value, which is the maximum for the problem given. So more than one solution. That's also an exceptional case. The last one is redundancy. Redundancy means which does not contribute to the feasible region. For example, let us say same this line, this one, maybe this problem. All the lines are marking down, except there is a one line which is not at all coming to this part. This line is completely different and going up. Means redundancy. That means all are following one trend, but this line is completely deviated from the given lines. So this sometimes one line or more than one line are not with the given other constraints. They are isolated points. It means redundancy. The problem itself is a redundancy. That means the problem cannot be solved by LPP. Is it clear? So these are the 4 exceptional cases or special cases in LPP. Because as a question given in last time in the exam, so that's why I am marking 4 important points. Very simple. First one, no feasible solution. That means there is no feasible region. Second one, more than one or two points. Third one, open-ended. That's called unbounded. Last one, redundancy. Is it clear? Fine. So the LPP problems in this unit you get either LPP problem graphical or simplex method, nothing else. Adhigani you can either what is the compulsory also. So we solve both LPP problems to chase. So we have started notebook characteristic unit number 1 lo chese problems ni meer graphically solve cheyandi. Graphically solve cheyandi. So you will see what is the feasible solutions. So in the next class we attempt the simplex method. Simplex method, very tough method. Fine. It needs 1.5 hour time to completely go step by step. I solve along with you. The step number 1 will solve. Step number 2 after completing step number 1 only I move to step number 2. Everyone. So I will solve together the simplex method in the next class. Okay? Then accordingly you will see what to do. Fine. Because either simplex method will come in the exam or